Tag. SQLite for C++ developer. So maybe a little bit more practical talk than the first part. I hope you find it interesting. SQLite was developed about 2000 from D. Richard Hipp, and it's for Twain Richard Hipp. Very long I was reading Doctor, but maybe that's just because I'm from Germany, but it's Twain Richard Hipp. And it was developed actually as a kind of a stub, is like I would describe it. So he was tired of setting up a whole database system like Postgre or Oracle just to create some GUIs. So he created basically a stub SQL server, and then he put the source code into public domain under no license actually, and this took off. So it's very widely used today. So who is actually a SQLite user here? Do we have some?
It used to be, as you know.
Yeah. But actually it's like this, you all should have raised your hands because you are all user of SQLite. SQLite is basically the widest spread software in the planet. It's also in space. You have it literally everywhere. It's on every mobile phone, exactly. It's on every computer in multiple versions. Routers you have at home, doesn't matter. You find it maybe even in a disk machine. So it's everywhere. So I ask this. So, but the question is also, what is SQLite, right? Because a lot of people say different things. So it's definitely not a small version of MySQL, Postgre, or any other database system. The limits from SQLite are rather huge. So you can create 140 terabyte big databases. So this is not a small something with a theoretical number of rows, because first you run out of disk space, and this disk space is just calculated. It was never tested because there is no test suite with such disks attached. So it is a full database system, and it can be quite huge. So it's definitely not a small something. But it's a zero config relational database, and it can be statically linked to your application. So what does this mean? It's shipped as a single C header and a C source code file, so it's very easy to add to your project. It works, the default are fantastic. However, you can fine-tune. There are a lot of compile time options. I could open them, but they are really so the compile time options. I don't go into the details because they are endless. So zero config doesn't mean there is nothing to config, but you just need to read the first chapter here. This is the most common you would like to config when you're up and when you're running with this. Oh, my presentation is gone. So back on track. I will not open any links anymore. What was it? Okay, so zero configuration can be statically linked in your application, in opposite to other databases. They run in their own address space, and SQLite is in your address space, so it's really in your application. When you run with a SQL server, PostgreSQL, you name it, it is an application somewhere. It's maybe not even on your computer. So SQLite is always in your application, and this is great. It's a relational application file format. So the user defines how to use SQLite. You can use it with threads, you can use it without threads. Multiple writers is not the primary use case, because SQLite does not table-based logging like other databases. It always logs the whole database file, since it's embedded, and you can open the file from multiple applications. So when you write, the whole file will be logged. It's a relational database with all features like transactions. So it's a good own file format if you need to spare configuration values and you always want to have a consistent state. So if you read data in and you want to write 3 different things to save your state, or nothing, you don't want to end up with a half-finished state because someone put the power out, then this is what it supports. So it's also a good key-value database store if you want to write data. And SQLite is actually much, much more. It has various extensions. Since recently, well, already 2 years or so, JSON support. You have full text search, R3 tables for GIS applications, CVS tables from files, so you can write your plugins and open CVS files as they would be a table, and then you can also make it for other formats. It's a great open source project. I said it. Here is the source code, and first it was not thought about it, but then it became copyleft. It's excellent tested. I said it is in space. It's in airplanes. It's everywhere. It's super documented, and it can also be used as an in-memory data store. So you can create a database just in memory, which exists just for the runtime of your application, which is a very nice feature if you need it. So basically, this is what SQLite is in a short summary. Any questions to this so far? No? Good. Then performance. Originally, I had a little bit a different title for this presentation, and I have taken it away, but it's still here. So every presentation needs charts, so I've added some charts. And this is my performance visualization. So X is the runtime of the application code, where our C++ code is, and the underscore is the time spent in the database call. When I say select or something update, you are in SQLite land. So this is when you use it, actually. You spend the most time in the database. And you can use any library available to talk with them. It will be like this. If you handcraft your C++ code, you will not notice any difference. And I tried it, and it's devastating. You spend all the time in the database, and you think and there is no optimization. If you really want to do optimization, you need to understand SQLite and database normalization. So SQL and database normalization. If you have a database where this matters, if you have a database where I say I just use it as key value store, there is not much to optimize. But if you have complex structures, then you need to learn about this thing, because there is where you optimize stuff, and there where ready-to-use library will not help that much. But I said there are different things about performance. So performance can be time to market. It could be daily changes requirements, like customer needs this, this, this. And you might want to also write the application which runs with whatever database backend you like a Jira, for example, a backtracing system. It says, well, you run on your computer and you define which database to use. This is actually mostly not what we do in C++, right? Or especially in embedded land. So when I care about performance, I have to look at this stuff, which is my SQL saying. Do I have a good database normalization, which is a data-driven layout? Do I have the indexes there where I need them, not there where we think, or some two things there should be? And if it becomes really hard and you have really complex queries, you either might do one query plan execution, look into how a query is executed, and then you can rearrange the stuff. But mostly you don't need this. So this is what I have to say to performance. Any questions to this? Well, great. So then my Learn SQL, it's simple, beautiful, and fun, because this is where performance comes from. Since C++ 11, it's great to write. I mean, when you have written in your source code file, pre-C++ 11 multi-line strings were a pain. Now with raw string literals, you just develop in your whatever tool you use to write your queries, and you copy it into the C++ code, and you're good to go. It's very convenient. SQL is fun and has cool words. First generation declarative language, relational algebra, tuple-related algebra, aggregate functions, scalar functions. So if Haskell developer come to you, you have also something in the repertoire. But this is not just a joke. If you learn a little bit about databases, you get a lot of things what functional programmer does. When you have a list of data and you manipulate it, or you select something, or you transform something from A and B. And it's all about data. So DDD is data-driven design, but it's also data definition language, data manipulation language, and data control language. All SQL databases have this. SQLite data control language is just file permissions. I can say a user is not allowed to access the file, or is. In other languages, you can create users, create groups, and add them with SQL statements, and this is pretty cool. Data definition language is how you create your tables, and data manipulation language, insert, update, select and apply functions to this data. So, entity relational crash course. So, in a database, you define entities, and these are basically your tables, and columns are attributes, and attributes might have constraints. Let's say an attribute is allowed to be between 0 and 100, or it's the birthday, it should be not more than 120 years ago, or something like this. There might be relations between entities. So there's one-to-one relation, one-to-many, many-to-one, and many-to-many. And the goal is, when you create your database, or you normalize your data, is to keep redundancies to 0, and to ensure data correctness and storage level. So this is a most simple example I can think about it, what is meant. You have an artist, and the artist has tracks. And we have a reference from the tracks to the artist. So we cannot create a track without an artist. It's not possible. Same way, we cannot delete the artist as long as there are tracks. Or you make a rule that say, when I delete the artist, also all tracks will be gone. It's how you define your relation. And this is the most simple for a one-to-many relation, where you define, where you apply normalization. And the well-defined storage is always in the well-defined state. So if it's written on disk, you can trust this. And a huge part of our civilization is on top of this. If it wouldn't be like this, we would have really headaches. But in databases, we trust. And this is you can utilize this stuff when you use SQLite in your C++ application on an embedded system. So you can utilize this. So SQL, since the key value storage has popped up, becomes, oh my god, SQL, but it's just another language. A few days and you have it. Insert, update, delete to manipulate data. Select with ordered by, group by to give me data. You can apply aggregate function over a whole data set, where you give me the average weight of all items in my database, or give me the average costs of all my goods that's in this category. You can apply scalar functions like trimming things. It's for each value in the result. And then we have joins, of course, the relations. But it's just another programming language, so it's not really hard. So if you think that this is something simple, then you will learn it very fast. And oh my god, I said joins, right? Well, I mean, that's it. Yes, Mengen sets things. This is everything you need to know about joins. If you write this out and put it on your table, when you learn SQL, that's it. So you get everything from one, plus where is the relation to the other. I want just what has a relation between two things. I want everything from all. What is not here is the Cartesian product. I don't know how to visualize it. But it's really not that hard. And this is beautiful. So when you learn SQL, and then you realize, oh, I can replace my code with an elegant SQL command, where I say, hey, give me the data that fulfills this criterion, and apply this transformation, and it's a string like this. This is beautiful. And you ask for data and information, and you get it, and this is beautiful. Yes, and with SQLite3, it's even more fun. because you can register your own C and C++ function for SQLite. So you could say my foobar, and you could say select my foobar from whatever. So my foobar field name from table, and my foobar will be applied to any value. Or you could make your own aggregate functions. So you can really interact with the data and manipulate it and extend it. And SQL databases are event-driven, so they all have support triggers, also SQLite. So if you have an event on data, on insert, on update, on delete, you get a notification before and after. And then you have events, and then you can make this very beautiful. And you can do a lot of more, so if you start to play, you develop a lot of ideas which just need a use case. But it's a fun toy. So yeah, this is, the basics are simple. Can be learned very quickly if you want to learn it. Not everyone in the project needs to be expert, but before you learn a DSL of any framework, learn SQL, because you can put it on any database system. Put the data where it should be, relational storages, and design your data. Enterprise relation models have more value than object diagrams. This is a personal opinion, but... And demo time. I didn't do this, but I have some SQL here. And I thought I will execute this. So I open an in-memory database because I don't need it anyway. I throw it away, and I execute this. So SQL is not just, I mean, to be fair, this is a fixed point query, so it's to process relational data. This is outside of relational algebra, but every database system supports this, and you can actually solve Sudoku with this. I just need to have a GUI because the input looks, but maybe in the future. So, yeah, learn SQL. It's really fun. Okay, any questions to this so far?
Yeah, I have a question.
Yes.
If it's so powerful, why is it called light?
SQLite, you need to ask the author basically. But it is lightweight because it is in your process. I mean, if you do nothing, it doesn't need resources. Right? When you put up your local Postgres or MySQL database, you will always have a process that does something, and you will have your program. And the other stuff is just data on a disk, and you don't even call it, right? So there is no management. You are direct on the data. Okay.
Yeah, I think light refers to the overhead.
So light refers to the overhead. So here, very excellent.
There's almost no overhead. Yeah. As you said, one file, almost no memory overhead, no disk overhead.
Exactly.
The code base is very small as well.
Yes. I mean, the file is really huge, so if it's developed as multiple files, but then there is a program that takes all these files and puts it in one file, and this is really, really huge. So coming in the debugger into this file is interesting.
So
but you can do it.
Or, can queries be optimized during compile time?
We will come to this.
Okay.
Anything? Okay, some code, because this is C++. It might be a little bit fast, but the main point is not to memorize everything, but I show now to see it, how simple it is, so you can enjoy the trip. So create a database connection in SQLite. It is a C interface, right? So we use SQLite open with a name and a pointer to a pointer, and if it's an error code, then you know the C code, right? If we have an error, we need to close it. We use the database and then we need to close it. So in C++, we will do it like this. We define a type, we call it connection, database, whatever. I don't even care about the type of SQLite close. It's the type of the function, right? I take a unit pointer because I think it's a proper type for it. And I encapsulate this call to return a unit pointer, if it works. If not, you need to define your own error handling. And from now on, you can use it like this. And you have a database connection. And this is already enough to execute arbitrary SQL statements. So I've written a sample function which is execute. It takes a not null. This is borrowed from the Microsoft support library. Database and some string. In future, this should be possibly a string view. And we encapsulate we have a pointer to an error message we call SQLite3 with the database, the SQL. You could define a size, what you want to execute, and the pointer to the code you have not executed if you define the size. And error message have never had a usage for these two. And then the default C stuff. But I said we encapsulate it, but this is enough to create already things, right? So I can use my open database, and I can create execute with the database and create things, where it's a nice thing to encapsulate SQLs in the function to return it as constant expression, because you want to unit test this stuff. And with, again, the memory database, if you play around, you don't need to create files. It's also very great for unit testing. So I've talked about transactions. So transactions is all or nothing. So if you make 3 inserts within a transaction, either all 3 succeed or no. Transaction is just another scope guard. And you can encapsulate it like this or something similar. Where you say, okay, I take a struct, it takes constructor, a database, and calls begin transaction. And if we haven't committed it, we will roll back the transaction. And if we commit it, we commit and notify that we have it. And this is just movable. The other operations are not required. And then you can put things in transaction. So this is really not hard. And the code looks like this. And you will either create the table plus 2 things, or you have nothing if it fails. So now we come to compile SQL, but it might be a little bit different than you thought. So each SQL is a string, right? And if you put it to a database, the database needs to compile the statement. So the first time it's always string, and small statements could be faster to execute than compiling the string. So you want to pre-compile it and remember this stuff. This is usually called stored procedures in some database system, and we can also do this with SQLite. And compiled SQL commands can have parameters, of course. So in SQLite syntax, they will look like this. We insert into something, and if it's a table with 3 fields, we take 3 different parameters. And you can think about this like a function, add 1, 2, 3, right? You can also give names to this, which is nice to the person who will read this code in 2 months or so. But they will still have indexes. And when you create this as a compiled statement, you can execute it and just apply the new values. And the string will not need to reinterpret it. It will be just executed by applying the values. And creating a compiled statement works like this. It's the usual C interface from SQLite with a return value. We take the database, we take the string, links, a pointer to the statement pointer, pointer to a pointer in C. And I think this is the error message. I would have to look it up. And if the return value is not okay, you need to do whatever you have to do. And then when you use the statement, you execute as many things as you want, or delete stuff or whatever. And then you need to use finalize, because otherwise you will have unfreed resources, and you don't want to have this. And we will do it like the database in C++ and encapsulate it in a unique pointer, call it statement or whatever. And the concept is the same. We take the database, we take maybe a string view in future, we encapsulate the code and put it in our unique pointer and return this. And then we don't need to think about freeing resources, which might have bad side effects when you close a database and you have statements open. So this problem is solved. Then you create your things. And here we have The select star is wrong. Sorry for this. It should be insert into things, values, and this is the compiled statement. Or you could also select from things. It doesn't matter. Setting statement parameters. Yeah, you have Lightning talks about this, how to do this with templates and so on. Point here is to demonstrate there is SQLite bind type functions, and there are not that many SQLite types. We have basically two categories. One is for int and real value, so floating point values, and the other is for strings and blob binary data. So here is no big surprise. You call SQLite bind int in 64 float. You take the statements, the index, and the value of the type, of course. If it doesn't return SQLite, okay, you can throw. For text, you need to define a pointer to the begin, like typical C stuff. How long is it? And here you have a parameter where you say, oh, SQLite, please manage this data for me. Or you say, then it needs to be copied, of course. Or you say, okay, you just get a pointer to this and I will manage the resource. So if you have large pictures or something like this, you want to manage the data. So it's a little bit hard for a library to generalize this, so it's better to write it your own. And that's it, how you set parameters. So the types is int 64 double. Then you have, of course, null. So you can set the parameter to null value. Text 16 or text 64. Text 16 is, of course, a Windows relic. Use Unicode and then you add text. And blob is in future as the byte. Yeah, I had never used for it, and I will run away if I have a project with them. And so as said, SQLite transient and SQLite static. Either you manage the resource for blob and text, or SQLite will do it. So now when we select data or do something, we want also to handle the result. The SQLite function is SQLite step on the statement, which we have created. And if it's a insert, delete, it just says OK or error. This is the first case. If it's a select statement with data, it will say, OK, I have a row of data for you. Or when you're done, there is no more data. It says, OK, we are done. So this is the return value of SQLite step. And one way to do it is to implement. We can implement it as we want, but give me a callback. And if there is data, I will call the callback. And if the callback says continue, I will go to the next row. And then the user doesn't need to write loops anymore. So this is convenient. It's just a function, and you will call it with the statement. Or with the statement, you can then access the data. But the loop is gone. We will see it in a moment. So the callback can be a function, lambda, whatever. So the callback is just a function that takes SQLite statement, which guarantees has a value. It makes things easier. And the run function, if we would implement this is a little bit okay. We have a reset guard. So if we don't step with a select statement to the end, the next time we call the same statement, we want to start from the beginning. So we need to reset it. So it's just another scope guard, which we reset when you exit the code. It will call SQLite reset on the statement. This is just, okay, I pose a little bit with source code. I've moved the inner loop to something which you can unit test. And this is how you execute the statement. So you call step on this. And if you have a callback, you call the callback with the statement. And then the loop is actually empty, and you can unit test this. This looks maybe a little bit wild, but you can, as I said, implement it as you want. And doing this way, you could move this to a function and write unit tests for it, which is nice to write unit tests for inner loops, because there are no inner loops longer. And the callback would look like this. So the implementation, you can copy it from the net or something like this, but you would implement the callback. And you would say, okay, for each column in the statement, there is a row, and then I process this. And you do it by, okay, what is the type? Either you know the type or you ask for it. And if it's null, okay, in this I just write null. If it's a 64, I will access the integer. If it's a double, I will access the double. If it's text, we need to get the pointer to the first text, and then we need to get the size, and then we can copy it into a string. And blob would be actually the same, but I just read out blob because it makes no sense. So basically you get the statement, you ask what is the type of the first column, second column, third column, and depending on what you get back, you do your actions. And this is how you access data from select statements. You want column counts, how many columns are there, you want the type of a column, you want the size possibly if it's a string or blob, and then when you know it's int double, you access it. And that's it. That's the basic to deal with SQLite, so it's absolutely not hard. We have SQLite3 to open, execute arbitrary string, prepare to generate prepared statements, step plus handling of the return value to execute the statements and handle the results, bind data in for parameters, and column type plus helpers to get data out. And when you're using this, it looks actually like this. You open a database within the transactions and create statement, and I call run with the statement and dump the current row with the function we have written, and it will just write out what this is. Okay, here is a little bit on row. When we have our callback, it should possibly be for auto column in columns. So if you want, you can implement this. It's not a difficult action, or you can copy it when you find the type. Okay, security. Let's look at security. So say we create a table and we add, so this is the create table, what we knew. We add something and we add the initial thing, and then we return the statement. That user can apply the statement and add additional things, right? And here bad things happen, right? So the user makes a mistake, so we return the first. So 1, this is correct, but this should actually be a double, right? But these things happen. And SQLite does duck typing. And this can be a feature, but it can be hell if you don't want it. So SQLite, when it create a table and say, hey, I want this table as an integer, it says, okay, it's a hint you want the integer. But actually, if you give me a string and you don't protect it, I will store a string there. And when you ask for the data and you ask for int, I will interpret it as an int, and it has conversion rules that apply. And they may not be as you ask. So if you have a callback print things, and this is just get integer, get text with point and size, and get double, because you say, I know the type, right? What else shall it be? And you say, give me the ID, the name, and the value is double. Then bad things happen. So if this is the code, the first thing, our generic function where we ask the type and then take action, it will find out that it's second. But the second function where we say, hey, what else shall it be? Because I'm the developer of it, I know what it is, you will get a 0. And this might be a very expensive mistake. So this is something you need to keep in mind, duck typing in SQLite, which can be a feature. Yes, if you don't care about the types, someone else will do it. Maybe not as you want. Okay, back to this. If you know what column is, we could actually work with DB value types, and we could specify the types. So if we have a prepared statement, we can execute this with an integer, with a string, and a real value, because we said integer, text, and real. But if we execute it like this, it will throw an exception. So this is one way to implement the type security if you don't want to implement the SQL on the database layer. You could also make a trigger on insert data. I expect this to be an integer, and if it's a string, you say, okay, error. But if you want to make it in C++, you can do it like this. And the same when you select data, when you know what the column is, it would call it field in a row. So for each row in the result of a select statement, and for each field in the row, you can encapsulate this very easy to get the type, get the storage type. So you can have actually two types, because you could say, okay, I want a variant type, but then you have, okay, it's a variant, but what is actually the underlying type? It could be integer or string or whatever. So there are two properties. And if you define no types, you would get a result something like variant int, variant text, and so on. So at least you will not have undefined behavior or work with wrong values, because if you say on such a column, give me the integer and it's a string, it can be implemented, hey, you want the integer of a string, throw an exception. This is what happens here, right? So give me a data set, select, I specify the types, and if they're not as expected, this will already throw. And here, okay, I have to check for null, because it could be null, right? So these are ways to implement security in your C code. You can look at this library. It's a C++ wrapper, which is one of the hobby projects I have. It hasn't much progress since I make this group here, but I do not recommend usage of it anyway, because write your own stuff. As you have seen, it's so easy. If I show the source code, which we have written, actually all the code I have shown, it compiles. It is 100 row the not null from the GSL library, and then it's pretty, you can write this in 2 days. Right here is already the example stuff. I will put it online, you can copy it later. So, but it supports what I've showed you. Types in, types out. You could make it also, you could define compile time types and take parameters as a tuple, for example, and you put in a type list. It has no performance impact at all. I've tried it. So if you make this at runtime and compile them, it's in the context of the application. It doesn't matter. But you can look at it as a inspiration. Yes, and that's it. SQLite for C++ developer in a nutshell. Parts of the presentation have been handled too short. Request a workshop. We will do one for you. You can also ask us C++, Sweden CPP. That's it. Thanks for listening. And if there are any questions, we can do questions. If not, we can maybe get something to drink for the rest of the evening. Yes?
You said it was used in the embedded system. Can you use it in a small microcontroller?
Well, I don't know how small it is. Usually the embedded systems I run, they have an operating system. You know, there are embedded systems without operating system. I have at least a memory management unit. So there they are. I don't know how much you can scale it down. You would have to look up what is the smallest possibility. But I wouldn't be surprised if it's run on